Hello everyone, today we're going to look at this system of three linear equations in three variables, each missing a variable term and all three containing fractions. As we normally do with any one equation or system of equations containing fractions, we'll go ahead and clear the fractions first and then take it from there. So to that end, we'll go ahead and multiply the first equation by 8 on both sides, the second equation by 4, and the third equation by 2. And we end up with, don't forget that when you multiply 8 here, you have to distribute, and you also multiply on the right side, 4 on the left side, and we distribute. And the same on the right side, 2 on the left side, and don't forget to distribute. So we end up with new equations. We end up with 32x plus 56y equals 157. The second one becomes 32x plus 8z is equal to 61, and the third one becomes 12y plus 4z is equal to 27. Now, the way we normally approach systems like this with a missing term is we try to eliminate one variable from two of the equations in a way that it creates a new equation which has the same variables as the third equation. For example, we notice that x would be very easy to eliminate from the first two equations because we can just go ahead and subtract the equations to eliminate x. Some people think you can only add equations, but remember that you can also subtract equations. So that's exactly what we're going to do. I'm going to bring the first two equations over, so 32x plus 56y equals 157, 32x plus 8z, notice not y but z, is equal to 61. So now we go ahead and subtract these two equations. These two eliminate. Now, the number one error students make when solving an equation like this is right here. They go ahead and combine those, but you can't because this has a y in it and this has a z in it. So what can you do? Well, you just keep both. So you get 56y, don't forget you're subtracting the equations, so minus 8z, and on this side we get 6 and 96. Now we take this third equation that we had already and we bring it over here, put it below this one, so we get 12y plus 4z equals 27. Now we have ourselves a new system of two equations in two unknowns, the same two unknowns. We know how to solve those very efficiently using elimination, and this is a particularly easy one because all we have to do is multiply the second equation by 2. So we leave the first equation alone, 56y minus 8z equals 96, and we go ahead and multiply the second equation by 2 on both sides. And don't forget that when you do so, you have to distribute. So we're gonna, let's see, this tool is giving me problems here. Let me see if I can get this going. So we're gonna multiply 2 on the left side and also 2 on the right side. And here we distribute. So we end up with, let me go back to my other color. So we end up with 24y plus 8z is equal to 54. Now we're going to go ahead and add the equations this time, and we end up with 80y on the left side. The z's cancel out this time, and we get, don't forget that was 96. Forgot to write the 6 previously. So when we combine those, we end up with, let's see, that's 140 and 10, so 150. Now we divide both sides by 80, and we get y equals 150 over 80, and the 10s can cancel out, so we get 15 over 8. Now we're going to take this 15 over 8 value for y, we're going to plug it into any of these 4 equations would work, and I'll just go with this one. So I get 24 times, instead of y, we're going to put 15 over 8 plus 8z is equal to 54. And now we're going to cross cancel here to leave us 3. So we get 45 plus 8z is equal to 54. So we end up with 8z equals 54 minus 45. So 8z equals 9. So z equals 9 over 8. So now we have z and we have y. So we're going to take those two values and go into one of those first 3 equations to get x. We can actually use just one of them. We don't need both. So I'll just go with the second equation and I'll plug in 9 over 8 for z. So we end up with 8x plus 2 times, instead of z, we're going to put 9 over 8 equals 61 over 4. So we get 8x. Notice here, these two cancel out. They leave us 4. So plus 9 over 4 equals 61 over 4. If we clear the fractions quickly by multiplying both sides by 4, so we're going to get 4 times that, and because of distribution, 4 times that, and then 4 on the other side. So now we get 32x. I'll just keep going with blue, plus 9 equals 61. So 32x equals 61 minus 9. So 32x equals, that's 9 from 11 is 252. So we get x equals 52 over 32. And I know that 4 goes into 52 13 times, and it goes into 32 8 times. So now we're ready to write our system's solution set, which is going to be an ordered triple, which starts with x, so 13 over 8. Then we put y, which is 15 over 8. And finally z, which is 9 over 8. Anytime that time permits, make sure you check these. I've already done so previously, so it works. And that basically is how you approach one of these problems. So be safe until the next time that we meet.